Good afternoon, my name is Sophia Garcia, and today you will be learning about De Morgan's Law and how we use it in probability. De Morgan's Law is two statements that describe the interactions between various set theory operations such as union, intersection, and complement. Recall that the intersection is when sets A and B consist of all elements that are common to both A and B. The union is when sets A and B consist of all elements that in either A or B, including the elements in both sets. The complement is when the set A consists of elements that are not elements of A. The complement is just simply an event that occurs when the other does not. The shaded region is a complement of the unshaded region because what happens in the unshaded region does not happen in the shaded region. The next couple of slides will give more clarity. To explain De Morgan's law further, let's start with the intersection. De Morgan's law states that neither A nor C equals not A or not C. We're going to prove that statement by inspection using these Venn diagrams. Here we are going to prove that the complement of A union C equals to the complement of A intersects the complement of C. We're going to use the following data sets you see here to do this. We're going to highlight the complement of A union C. Now, we're going to highlight complement of A, and we are also going to highlight the complement of C. Notice the data set above belongs in neither unhighlighted part. By inspection, we can see that this data set fits in neither of the Venn diagrams. And because of that, we have proved by inspection that neither A nor C equals not A and not C. Because notice, this data set, none of these numbers are in A or in C. They are in these other data sets right here, B and D. Okay. We just proved 1/2 of De Morgan's law. Now we're going to focus on the union. De Morgan's law states that not A and C is equal to not A and C. And it sounded like I repeated myself when I said not A and not C. Not A and not C, the first one is in parentheses, and the other one, they are separate like they are here. And we are also going to prove that by inspection by using these Venn diagrams down here. Here we are going to prove that complement of A intersects C equals the complement of A union the complement of C. We are going to use the following data, what's it called? We're going to use the same data sets as last time, these up here, to do this as well. We are going to highlight the complement of A intersects C, then now we're going to highlight the complement of A, which is region here. Anything that does not belong in A. And we're going to highlight the complement of C, which is everything that does not belong in C. Notice the data set above belongs in neither in the unhighlighted part, which means everything, all the data sets you see here belong in these spaces right here, unlike the last example. By inspection, we can see that the data set fits, like I said before, in both sets of Venn diagrams. Because of that, we have proved by inspection that not A and B in parentheses is equal to not A and B, not in parentheses. And well, this concludes De Morgan's law. Thank you for learning with me today.